Okay, page 3. Let me add a couple things in here for you. The number 17, don't forget, I mean for that to be a couple Pythagorean theorems, and that y is 5, and that's a right angle in there. So, for instance, if you want to find x, you're going to do 5 squared minus 4 squared equals x squared. Whoops, sorry about that. Weird. I can't get my handwriting to work. There you go. And that's the same thing as doing or 4 squared plus x squared equals 5 squared. And then you have to subtract 4 squared anyway, and you end up with this thing up here. Just to finish that out a little bit, let me clean things up just a tad bit. Let's finish that off. That'd be 25 minus 16, which would be 9. It'd be x squared, and hey, 3 equals x. And that'd be, we could then go in and solve for z, another Pythagorean theorem. So it's just a couple Pythagorean theorems away. Okay, so on we go. So the next one is 18. This it's an inscribed angle, so it's half as big as the angle up the arc measure. So what I have is half the arc measure here equals 8x plus 27. Or you could represent it as 2 times that smaller angle equals the other 23x minus 23. So they have a 2-to-1 relationship. You know, they arrive at each other. If you multiply both sides by 2 in the top equation, you end up with the bottom equation. So they're all very much related. Same general concept. Okay, so I'm going to clean out just a few things in there. All right, let's finish that off. If you distribute, there's your distribution. You want to get variable on one side, subtract 16x. Here you go, and then you want to add 23 to both sides, and then divide by 7, and you've got x equals 11 for number 18. Okay, so for number 19, this is, remember, if you take a look at this problem, it's, let me back this up just a tad bit so you can see where I got all this stuff from. 14 squared is, you know, this outer leg times the inner, or the whole length times the inner, that goes with this type of problem. So here, let me restate the whole theorem that goes with this. Let me back that up. The inside piece times the whole length, so that'd be 8 times 8 plus x. That's what you're seeing right here. That's the inside times the whole length, equal to the inside times the whole length on the other side. Well, they're both 14 on the top side, so it's 14 squared equals 8 times 8 plus x. And if I finish that out just a little bit, distribute the 8s to get 64 plus 8x. 14 squared is 196, subtract 64, and then divide by 8, and you get 16.5 for x. So again, the big property that you want to notice, be careful with, is this one right here. That times itself, the inside times the whole length equals the inside times the whole length. And that's the big property for that one. Part B, let's call it over here on the right-hand side. That one is the product of the segment pieces, like 12 times 5, are equal to the other product of segment pieces, 6 times x. And 12 times 5 is 60. And that's 6x. Divide both sides by 6. 10 equals x. And that's the name of the story on those. I'm going to go to the next couple, so hang in there. Okay, so we're looking at number 20. This is a rectangle, and the reason you know, and it isn't just a guess, the things that you make it a rectangle, in a grid, you can be assured, if you're talking about vertical and horizontal lines, that is a right angle in there, so we're good with that, right angles. And the lengths of each side, opposite sides, are congruent. So this is 4, 4, and the height here, 3 above, 4 below. It looks like this is 7, and this one's 7. So congruent opposite sides and 90-degree angles, which is confirmed by drawing this in a grid. 21 is the big scale factor question. Scale factor is a ratio of sides. So the two sides that we know are 9 and 6, so that'd be 9 sixths or 6 ninths. Both are fine. 9 sixths is also known as 1.5, and 6 ninths is 0.6, repeating, 66%. Fraction's good. I'm just looking for the ratio of two sides. Now, to find x, we're probably not, you can use the scale factor to go find it. Remember the two scale factors, there's an enlargement factor, which is the one that's greater than 1. That would be from, I could multiply by that factor to take 8 times 1.5, or 9 sixths, and I could get x. Or if I use the shrink factor, the 6 ninths or 0.6 repeating, I could take 20 times that 6 ninths or 0.6 and I could get y, for instance. Now I'm going to use ratios, equal ratios, otherwise known as proportions, to solve this. So 9 over 6 equals 20 over y would get me y. 9 over 6 equals 20 over y would be a way to solve for y. Cross products are equal. And 6 times 20 is 120. And then y equals 13 and a third. Then I'll do a proportion as well to solve for x. So I could do 9 over x equals 6 over 8. That's just an example. 9 over x equals 6 over 8. So that would be 6x equals 72. Divide both sides by 6, and x equals 12. And that'll finish out those problems on that page. Next set coming right up. Okay, so for that, oh, and there's one more on this other side. Write the similarity statement for that last one. Triangle ABC is similar to triangle DEF. And the similarity statement is when you line up the congruent angles with each other. A corresponds to D, B to E, and C to F. And you have to put them in the same order to demarcate where the equal angles are. 22 is you got this boy looking up at 40 degrees. So there's our 40-degree angle. He's 1,000 units away. What's our unit? Yards. So he's 1,000 yards away. And this thing going up in the air perpendicularly, as all things are. Elevation is what I'm looking for of the plane up there. So that's going to be my big X. So angles and sides together means trig is going to happen. The sides I happen to have are the opposite and the adjacent. So that's a tangent ratio issue. So I'm going to do the tangent of the angle, 40 degrees. So this is the setup. You always go trig function of the angle equals the opposite side over the adjacent side. And when you're done writing up this this equation, it's going to be solvable. Tangent 40 is a number, so we're going to go get that from a calculator. And then we're going to multiply both sides by 1,000 to get this solved. So I'm going to make just a little calculation underneath here so you can kind of see what I'm doing. But I'm going to end up multiplying both sides by 1,000. So I'll have 1,000 tangent of 40, again, which is a number. Maybe I'll put that in parentheses. Equals, and then I'm going to multiply the other side by 1,000, and it cancels, so it's just x. You know, when you multiply by 1,000 up here, it cancels with the other, and it's gone. So x is going to be whatever 1,000 times tangent 40 is. And we get 839.1 yards for the elevation of that airplane. Now, the next one is one of those cool problems. Here's an arc of 89 degrees and 63 degrees. Sorry, those degrees didn't show up. When the intersection's outside like this, that angle x is half the difference between those two. So I'm going to say 89 minus 63, and I'll get my calculation. So that's half of 26, and x then is 13 degrees. Okay, so half the difference when the intersection's outside the circle. The circumference, area, length of the minor arc, and find the area of the sector. The two that are on the final, so you can kind of just leave yourself a little, I can address those sometime if you like, but in 24, the only thing we need to find is the circumference, which is, the diameter is 36, if you double that radius, so 36 pi, and that's a perfectly good answer for circumference. And the length of the minor arc is going to be this little ratio proportion over here. You guys know how this goes. It'll be 100 over 360 is equal to the arc measure. Now the arc that I'm looking for is the one down here. Arc measure, let's call AB. You know, we'll go A and I'll put a B down there. So we'll call AB is to the circumference, and the circumference, again, is 36 pi. So a little cross product action, and we're home free. So I'm going to do a couple steps at once. AB times 360 is equal to, sorry about that, that's 100 times 36 pi. Okay, and then I divide both sides by 360. So we end up with 100 times 36 pi, and that times, or divided by, 360 degrees. And our resulting calculation is, it ends up being 31.42. So that measure of arc AB is 31.42. Okay. And for this one, number 25, that's really set up for a nice Pythagorean theorem. So you could do a squared plus b squared equals c squared here, or z squared as it's written. It's not really set up for solving in trig, but I could use a trig function to do that, but it's not set up particularly well. So I'm going to focus instead on, why don't you just look at the other two. This cosine of 35 degrees equals 2 over y as the setup for that top one. And then down below, this would be the tangent of 55 equals x over 3. Now what's important about these two setups, one, I know it's cosine on the top one because it's adjacent over hypotenuse. I always put the degree of the angle here. And then the other one is opposite over adjacent, so I know it's tangent of 55. Now both of these you start out solving the same way, it's a two-stepper on top. So 2 steps, because I have to multiply by the denominator y and then divide by the cosine of 35, which you may want to make a decimal. You're welcome to make cosine of 35 a decimal and to go from there. But let's just do it times y on both sides. I'm going to use a different color for all my solving. So we'll do times y here, and then the y's will cancel. And then your result is cosine of 35 times y equals 2. So maybe I'll just do it this way, y cosine 35 equals 2. And then I'm going to divide both sides by that cosine of 35, which you may have as a decimal, but that's fine. It's a value, 35, and that's going to get me y by itself. So y will be equal to whatever 2 divided by my cosine of 35 decimal or cosine of 35 itself. And I get about 2.44. Y is about 2.44. Now that one was multiplying by y and divided by cosine of 35. The bottom one, we're just going to multiply both sides by the denominator 3, and that'll get x by itself, and so we'll end up with x is simply equal to 3 times the tangent of 55, 4.28. And that's it. That closes out everything on there. The next thing is up, if you need a helper, I'm just going to post a picture of the key one more time of the extra review problems. But that's the end of the videos. Email with any questions, but we're pretty much down to the wire. Good luck out there.